Hello students, welcome to e-learning session. Today we will complete types of mixtures and valency. How to write valency of compounds from this lesson. So molecular formula and valency. We will also write molecular formula with the help of valency. Let's begin. Start now mixtures. So for this purpose we will take 3 beakers. This is first beaker, this is second beaker and this is third beaker. In first beaker we'll take mixture of sand and water. Now these particles are sand and upside there is a water. Now here we'll take crystals of CSO4 and water. When we stir it, what happens? It form a mixture. CSO4 get dissolved in that water and we see blue color solution here. Now here we'll take CSO4 and sand. Now what do you see? In the first beaker you clearly see the sand particles. In second beaker you clearly see blue color water. This is because of CSO4 water got blue color. While in third one we see blue vitriol, that is CSO4 crystals and sand particle. Now here the sand and water, they do not get mixed even after stirring. So solution is formed, but here we can see clearly separately sand particles. They do not get mixed, they do not get dissolved in water. Okay, this is a solution, but what type of solution it is? Heterogeneous. Heterogeneous means they do not get, the constituent do not get mixed with each other. When constituent get dissolved, now here water is solvent. Why water is solvent? Because it is in large quantity. CSO4 we took in small quantity. So it is solute and it is solvent. So together these two form solution. Now what color it is? Blue color. So here they form blue color solution. So only one. We do not see clear separately CSO4 and water. We see them together in one color. So it is homogeneous. While here we can identify sand particle and CSO4. So it is heterogeneous. Now in this activity we saw that in 3 beakers when we took mixtures, we saw heterogeneous type of mixture also and homogeneous type of mixture. In first and third beaker there are heterogeneous mixtures, while in second beaker that one is having homogeneous mixture. Now how these mixtures are classified? Here mixtures are classified on the basis of phases. What is meant by phase? Suppose take sugar and water in one beaker and stir it. What will happen? Will you see crystals of sugar? No. They will get dissolved in water and that's why we do not see the crystals. So here they form uniform solution. When uniform composition of means is formed, that is called as phase. So in second beaker we see single phase, while in first beaker there is no uniform composition. First and second beaker. We can clearly see sand particles separately than water from water. So there are two phases. One phase is of sand particles and second phase is of water. While in third beaker we can clearly identify that blue color blue vitriol and then red particles of sand. It means there are also two phases, one of blue vitriol and second one is of sand. That's why first and third beakers are heterogeneous type of mixtures. While second beaker is having uniform solution or composition, hence it is a homogeneous mixture. We'll understand more about phases in solid, liquid and gases. So all the particles of solid which stay together, for example stone, heap of sand, they are single phase. Okay. So a liquid substance along with all soluble substances dissolve together. They also constitute single phase. For example, sharbat. Sharbat, it consists of water, sugar, salt, lemon. So when all they get dissolved, they form single phase. While a liquid, now take water and add some oil in it. What will happen? Oil do not get mixed in the water. So here they form two phases, one of oil and one of water. But if we collect a raindrop together, so they form single phase. All the gases that are present in the air, they also form single phase. Okay, I think you learn about single phase and two phases, three phases. Okay, next part. Students, suppose we take in CSO4 in liquid form and we add sand in it, even then it form heterogeneous mixtures. Let us see. Now see, this is a solution of CSO4 and these are sand particles. So they do not get mixed with each other and they do not form single phase. Hence this is also heterogeneous mixture. So third beaker, even if we take in solid form or liquid, one in liquid and one in solid, even then they form heterogeneous mixture because they do not get mixed with each other. They do that in CSO4 sand do not dissolve completely. Now this is the activity printed on textbook page number 43. As per the activity, we have to take 3 beakers. Then in first beaker we have to take common salt, in second beaker we have to take sawdust, and in third beaker milk. Then we have to add water in all 3 beakers. So what will happen? Common salt plus water, sawdust plus water, and milk plus water. Can we see separately after adding water, common salt and water separately? No. It means separate. Aqueous means water. Phase not seen. So what type of medium it is? When even after addition of common salt, we can see through that water. So it is a transparent medium. So here components are not separated by filtration also. As per the activity, these are the 3 beakers. In first beaker, common salt is taken, in second beaker sawdust, and in third beaker it is white color milk. Now after addition of water, the solution of common salt and water is formed. Okay, here sawdust remain downside and water upside, and milk and water they get mixed. Now can we see through it? Yes. When common salt get dissolved, we can see through it, it is a transparent. Now what about it? Now it is transparent. Can we, now if we have to filter it, can we filter it? And can we separate common salt and water? No. Common salt is dissolved in water, that's why we do not separate common salt from water. Now sawdust and water, stir it. Okay, then sawdust slowly settles at bottom and water remain upside. What type of medium it is? It is aqueous phase, means water is there. But we can see through it. From upside we can see because water, clear cut water is there. So here, can we separate sawdust from water? Yes. We can separate sawdust from water by filtration. Now this is a third beaker. Here milk is present. In milk what is added? Water. Can we see milk and water separately? No. Separate aqueous phases are not seen. So can we see through the milk other side? No. It is opaque. And these components, can we separate water and milk? No. We cannot separate water and milk by filtration. Now we'll understand about solution. A homogeneous mixture of two or more substances is called solution. We already learned in the first beaker in above activity, a homogeneous mixture of water and salt is formed. So that is called as water and salt solution. or it is a salt solution. Now the component of a solution which is present in largest proportion is called solvent, and the other component which is in less proportion is called as solutes, and the process of forming solution by mixing solute in solvent is called as dissolution. What is it? Dissolution. Okay, we'll understand again it. Now see, here when we added water in common salt, what happened? This common salt get dissolved in water and a solution is formed. Solution of common salt and water. Now this solution, we cannot separate common salt from water by say, filtration, by hand picking, anything we cannot separate it. Okay, this is a solution. It is single phase, and as we cannot see salt particles in this water, hence it is homogeneous solution. What type of solution it is? Homogeneous solution. Now here, what is meant by solution? Here, this common salt, we are adding common salt in less proportion. That is only 1 teaspoon. And here, proportion of water is more or greater. So, this water is called as, what is it? Solvent. So, the substance which is in greater proportion, it is solvent. Which is in less proportion is called as solute. And these two together form solution. And the process of forming solution is called as dissolution. How solution is formed? This solution is formed by dissolving solute in solvent. Here in this case, common salt, it is in less proportion, so it is solute. And this common salt is added in water, so water is solvent. So in this water, what is added? Common salt is added, or in this solvent, solute is added. So when solute is added, what is formed? Solute plus solvent together form solution. So this formation of solution by dissolving solute in solvent, is that process is called as dissolution. So by which process solution is formed? By the process of dissolution. Okay, understood? According to the states of the components, solution can be many types. For example, the solution as seawater, blue vitriol dissolved in water, salt dissolved in water, then sugar syrup. They are the type of solid in liquid solution. Now take a beaker and add common salt in water. Now what will happen? After stirring, we see only water in it. Then this, why? Because crystals, these salt particles, they get dissolved in water. Now here, salt is in which state? Salt is solid. Water is liquid. So what type of solution it is? It is solid in liquid type of solution. What is it? Solid in liquid type of solution. Again, can you tell other examples? Yes. This is salt plus water. Salt plus water. Other examples? Okay. Sugar plus water. We'll take sugar plus water. Then third one, blue vitriol, that is CuSO4 plus water. Then potassium permanganate, K, this should be capital, KMnO4 plus water. Now what is this? Solid in liquid. When solid is added in water, solution is formed. Next type of solution is liquid in liquid. Now when vinegar is added in water, we see uniform solution. So that is liquid in liquid. Then when acid is added in water, what type of solution it is? Liquid in liquid. Suppose alcohol. When alcohol is added in water, Again, what type of solution it is? Liquid in liquid. Then if we take example of air, what type of solution it is? It is gas in gas solution. What is it? It is gas in gas solution. And suppose aerated drink, we always use to drink that thumbs up, Pepsi, etc. That cold drink. So what type of solution it is? Here carbon dioxide gas is dissolved. It is sparingly soluble in water. It dissolves sparingly. So when carbon dioxide is added in that liquid, what type of cold drink is formed? It is gas in liquid. So next type of solution is gas in liquid. For example, oxygen gas in water, then chlorinated water, or the example of, we'll take here example of chlorinated water. Okay, cold drink, you can write here also cold drink. So what type of liquid solution it is? Gas in liquid. Now till now, how many types of solution we learned? Solid in liquid, solid in liquid, then liquid in liquid, gas in liquid, gas in gas, and gas in liquid. Okay. The composition of homogeneous mixture, that is to say that solution, so it is uniform throughout that container, okay, from bottom to upside. So if solvent is transparent liquid, then solution is also transparent, and we this solution can easily pass through the filter paper. We'll see the second beaker, activity of second beaker, that is water and sawdust, and we'll learn suspension. Now when water is added in sawdust, sawdust remains separate from water. It is not dissolved in water. Okay, here the sawdust, we can see the separate layer of sawdust. Okay, so this type of mixture is heterogeneous mixture, and it is, what type of mixture it is? Liquid in solid, because water is added in solid. Okay, and it is called as suspension. What is it? Suspension. Suspension is always heterogeneous mixture. Suspension is always heterogeneous mixture. Okay, here the diameter of particle is greater than 10 to the power minus 4, 10 to the power minus 4 meter. Okay, hence light cannot transmit through it. How light will transmit when sawdust is there? Okay, so these particles can easily separated with filter paper. Suppose this is a funnel, okay, in which filter paper is placed, and this funnel, place it over a beaker. Okay, pass this solution through it. So upside, what we will see upside here, what remain upside in that filter paper? Sawdust. And what clearly pass through it? This is water. So we can easily separate this. Okay, suspension solid components are easily separated from that liquid. So these are the suspension. The size of the particle is larger than 10 to the power minus 4 meter. The size of the particle is always greater. They are opaque because light cannot transmit through it. We'll learn about colloid with the help of the third beaker, where water is added in the milk. Now milk is a mixture of proteins, fats, water, and other carbohydrates. That sugar is there, lactose sugar. Now here, if we use laser battery and pass light through it. So part of the light passes through it and part of the light gets scattered. So it is a translucent. It is not transparent, it is not opaque, but it is translucent. Why? Because part of the light, only some part of the light get pass through it, that is transmit through it, and some get scattered. So it is why this happen? Because of the tiny particles of milk phase. It is a heterogeneous because tiny particles remain separate and they are dispersed evenly in water. Actually, these particles, they do not dissolve, they evenly dispersed in this water, and the diameter of these particles is around 10 to the power minus 5 meter. So here in milk and water mixture, it is why it is heterogeneous mixture, because milk phase means milk particles do not get dissolved in water, they evenly spread throughout the water. Okay, that's why it become translucent as they get evenly spread throughout the water, and their size is 10 to the power minus 5 meter. So such heterogeneous mixture is called as colloid. Now they can easily pass through that filter paper because the means that filter paper, their the pores of the filter paper are larger than the colloid particles. Hence, through that filter paper, this milk particle get easily passed. So here milk cannot be separated by water by simple filtration process. Milk is itself colloid because in milk water is in greater proportion, and here solid particles are means present in the water. Milk, how it is formed? There are proteins, fats, so these particles are evenly spread. Hence milk is a colloid. And again the diameter size of the particle is 10 to the power minus 5, which is dispersed. There are, apart from milk, there are other examples of colloids such as smoke. This is solid in gas. And liquid in gas, examples are fog and cloud. Now molecular formula and valency. We know that in a compound, definite proportion of constituent elements are present. And these constituent elements, they form compound. Now there are certain number of atoms of the constituent elements which join together in a molecule of a compound with each other to form a molecule in a compound. So the molecular formula of compound indicates the number of atoms of each constituent elements present in one molecule of a compound. So molecular formula includes the information regarding the symbols of the all constituent elements and their respective numbers as subscripts. Understand this concept with the help of this table. Now this is a compound water. Water is formed. This is a molecular formula of water, H2O. So which are the constituent elements? Hydrogen and oxygen. How many atoms of hydrogen is present? 2 atoms of hydrogen and 1 atom of oxygen. Likewise, second example is hydrogen chloride. What is the molecular formula of hydrogen chloride? HCl. Now constituent elements, here we will write hydrogen, here we will write chlorine. And number of hydrogen 1, number of chlorine atoms 1. Then methane, molecular formula CH4, carbon and hydrogen. 1 carbon atom and 4 hydrogen atom. Magnesium chloride MgCl2. Here we will write Mg, here Cl2. 1 magnesium and 2 chlorine atoms. Here is the chart filled for you with water, hydrogen chloride, methane and magnesium chloride.